Okay guys, this is your video to go over your Uniform Motion Part 2 study guide, so make sure that you're on the right track. So I hope that you guys filled it out on your own so that you can just make sure that you're on the right track for the test on Monday. Okay, so first of all, we're filling in the triangle using our notes with speed, distance, and time. So hopefully you had those to look back on this. And you should at least remember that speed equals distance over time, and that will help you fill this in. If that's true, then the S has to go here, D here, and T there. Don't forget your divider bars and multiplication right there. Once I have that, I can use it to fill out these formulas here. So if I cover up the S, it tells me that speed is a distance over time. If I cover up distance, it tells me that distance is speed times time. And if I cover up the time, it tells me that time equals distance over speed. And that's how I got those. So now we can go through some of the math problems. So the question is, what is the speed of a dog running through a field if he covers 23.7 meters in 54 seconds? So from question number 3, we know that we're looking for speed. And it gives us 23.7 meters. Meters is a unit of distance. And he does that in 54 seconds, which is a unit of time. So I've got my given here, 23.7 meters, a distance, and 54 seconds. What I don't know is the speed. So the equation I'm going to use is speed equals distance over time. I'm going to substitute my numbers in there, 23.7 divided by 54, and I'm going to come out with 0.44, and then my units are going to be units of speed, which would be meters per second. For number 4, how far did the car travel if it went 75 miles an hour for 24 hours? So what it has given me is 75 miles an hour, which is a speed, and 24 hours, which is a time. And it's asking me how far, so that tells me I'm solving for distance. So my given is 75 miles an hour and 24 hours. What I need to know is distance, so I'm going to take distance equals speed times time. So 75 times 24, and I will come out with 1,800 miles. Miles are a unit of distance. So my next question, how long would it take a drag car traveling 115 miles an hour to run 25 miles? Well, how long says it's asking me for time. If I ask you how long it takes you to do something, you're going to tell me a time. 115 miles an hour is a speed, 0.25 miles is a distance. So my given is speed and distance. What I don't know is time. So I'm going to take time equals distance divided by speed, just like this, and solve to get 0.0022 hours. Next question, what is velocity and how is it different from speed? Okay, we know velocity and speed are close to the same thing, but just not quite. Velocity has one more aspect to it. So velocity is speed with direction. Speed does not have a direction by itself. So when we do a velocity, it has to be positive or negative to tell us whether it's going away from 0 or toward 0. So for number 7, we've got cyclist A and B. And so it's got a couple of questions about those guys. So at 14 seconds, which cyclist had traveled the furthest from the 0 point, and how do I know? How I would check that is find 14 seconds on the graph, follow it up. There he is, right there at 14 seconds, so I follow that on over to my position. Looks like he's a little over 8 meters away, cyclist A. While at 14 seconds for cyclist B, we're here on the line, so I follow that over. He is not even 8 meters. So that tells me cyclist A because his position is a bit higher than cyclist B at 14 seconds. I followed the graph. Next question. Do the cyclists ever go the same speed, and how do you know? Well, I can tell without even calculating slope because of the steepness of each line. This line is much steeper than this one, so that tells me that they do not go the same speed because both of them are constant because they're straight. So they do not go the same speed because the steepness is different. Last question. Do you think one cyclist ever passes the other? If so, who passes who? Well, if if I look at the steepness, this cyclist is going much faster than this one. So that tells me if he's going faster, he is probably going to pass him. So cyclist A will pass cyclist B. On these graphs, what I'm doing is I'm taking this information from the position versus time and I'm constructing what the velocity time would approximately look like. So segment 1 here, I've got a positive direction, medium speed. So, and it lasts about 3 boxes. So I'm going to put that about here, up above the 0 line on my velocity time graph. Second segment, flat, which tells me position didn't change. So there is no speed because it's not moving. And that lasts for about the next 5 boxes. So my speed's going to be right there on the 0 line. Last segment, very steep, positive direction. So much higher speed than my earlier positive. So I'm going to put it all the way at the top. But don't forget about your 3 dots because that finishes it off. Second graph, first segment, toward 0, which means negative directions, which means I should be down below 0. And it's about a medium speed, so I'm going to put it about right here, and it lasts for about 4 boxes. So like this. Second segment, positive direction away from 0, and it's about medium, so I'm going to put it about here for the next 4 boxes. Last segment, flat, no position change, so no speed, so I'm down here on 0. 3 dots. There we have it. My last one, my first segment is positive and about medium, so I'm going to put it about right here for the first 3 boxes. Second segment, negative and very steep for 2 boxes. So negative direction is below 0 and it's very steep, so it's got to be far away from this mid-0 point here. Final segment, very low, so not steep at all, so it's going to be slow moving but positive direction. So for the rest of the time, very low speed right here just above 0. Don't forget your 3 dots. Okay, now we just have to determine the reverse. Here's our velocity time, and we have to say what our position versus time would look like. So the first segment, positive because it's above the 0. Medium speed, half the time. So positive, medium speed, half the time. Followed by a segment that's negative, so opposite direction, same speed. So move toward 0 for the rest of the time. There we go. Second graph, we have a positive, pretty high speed for the first segment. So I'm going to take it about to there. Pretty steep, pretty fast moving. But then our second segment is much lower speed, so that means our steepness has to kind of level off like this. So that's what that would look like, all in the positive direction. Last graph, we have a negative direction, very slow speed at first. So I'm going to take it about like this, followed by a section at the 0 mark, and if it's at the 0 mark on velocity, that means no speed, so it was not moving, so stationary right here. Followed by a very high speed positive section, so super steep, positive direction. So there we go. Okay, so this last page, guys, is worth a lot of points, and it's almost identical to a page of your test, so make sure that you understand this. And don't forget your units. In this case, my velocity is going to have kilometers per second for the units, and I get that from this over this. Then I break it down by my segments and identify my xi, xf, delta t, and talk about my speed a little bit. So if I just do segment 1, xi, which is initial position, is right here at the 20. xf, the end of that segment, is there, also at the 20. The time that it took was from 0 to here, which is 45. And position did not change, so that means this object was stationary during this time. Segment 2, xi, where it starts, right here, again, 20. My xf is at this point now, so I've got to follow it over to my position, which would be 60. Then the time it took up was from here to here. So this is 75 and this is 45. Now, and in order to determine how long that went, I'm going to take 75 minus 45, which gives me 30. In this case, we have a fairly steep line in the positive direction, so positive, constant, fast. And then my third segment starts right here at the 60. Final position is here, which tells me 70. And then the change in time. So it went from this time to 120. So I'm going to take 120 minus 75, which gives me another 45 seconds. In this case, we have another positive segment, so positive, constant, but in this case, we're slow. So what's nice is that all your information is there now. So now we just have to calculate speed. And in order to do that, if you remember, your equation is xf minus xi over delta t, just like we did in that worksheet. So we just do it for each segment. So xf for this one is 20, xi for segment 1 is 20. The time it took is 45 seconds, so I've got 0 over 45, which is just plain 0, which makes sense. Flat line, it wasn't moving. So kilometers per second. Segment 2, xf is 60. xi is 20, and it went for 30 seconds. So I'm going to take 60 minus 20, which is 40, divide that by 30, and I'm going to come up with my answer, 1.3 kilometers per second for segment 2. Okay. Then segment 3, my xf is 70, xi is 60, and the time it took is 45, so I'm going to do 10 over 45. I'm going to divide that out, and it's going to come out to 0.2 kilometers per second. So those are the speeds I have to graph on my velocity time graph right down here. Since those are the speeds, I can definitely use a good scale on this. So I know this is for sure 0. Velocity is measured in kilometers per second. Time is measured in seconds, and I can just copy the time scale from right here. So skip one line, 30, 60, 90, 120. And I only have to go up to about 1.3. So I would maybe go by 0.5s. So 0.5, 1, 1.5, so on. And then, of course, you got to do your negative side. Okay, so that's all filled out. So now I just have to graph my speeds. So from 0 to 45, I'm going 0. So fill that in right there, right at 0 for that length of time. Then for segment 2, I went 1.3, which is going to be up here. And I did that for until between 60 and 90. So I'm going to go about like this. And then 0.2 is going to be down here really close to 0 for the rest of the, up until 120, not the rest of the time, up until 120. So right there. Don't forget your 3 dots. Last thing, what's happening during the first segment? Flat line, position did not change. The object is not moving. That's it, guys. Let me know if you have questions. Test is on Monday. Study hard.